So the problem states a ball is kicked off of a 15-meter cliff at an angle of 42 degrees from horizontal with a speed of 15.5 meters per second. So draw your diagram to start. You have your 15-meter cliff. You have your 15-meter cliff. A ball is being kicked off the top at an angle of 42 degrees from horizontal, and is being kicked at a speed of 15.5 meters per second. First, since it gives you a speed of 15.5 meters per second at an angle of 42 degrees, know that that's not your vertical or your horizontal. So if you make a triangle out of it, that would be your hypotenuse, and you want to use sine and cosine to figure out what your velocity vertical and your velocity horizontal would be. So if you use sine of 42 degrees, that's opposite over adjacent, it would give you sine of 42 is equal to y over 15.5 meters per second squared. Multiply both sides by 15.5 meters per second, and you get 15.5 times sine 42. Sine 42 is equal to y, which will give you an answer of y equals 10.37 meters per second. So that's your initial velocity vertically. And then for horizontally, you would do the same thing, but with cosine. Cosine 42 equals x over 15.5 meters per second. 15.5 meters per second times cosine equals x. X is equal to 11.52 meters per second. So that's your initial velocity horizontally. And you also know that your horizontal acceleration is 0 meters per second squared. So your initial velocity and your final velocity would be the same. So you also fill out like whatever else you know. You know that vertical acceleration is negative 9.8 meters per second squared because that's gravitational acceleration. And you know that your vertical displacement is negative 15 meters because you're going down 15 meters. Next, what you want to do is solve for, because you want to find out what the maximum height is, that's this point right here. And you know that when you're at your max height, vertically, your velocity is 0 meters per second. So using that, you can solve to find the time you get to your maximum point. So you would go here, use the acceleration equation, negative 9.8 meters per second squared is equal to 0 meters per second minus 10.37 meters per second over time. Multiply both sides by time. So you have 10 t times negative 9.8 meters per second squared is equal to negative 10.37 meters per second. Divide both sides by negative 9.8 meters per second squared. Use your unit analysis, and you get time equals 1.058 seconds. So that's how long it takes the ball to reach this maximum point. Using that time, plug it into the displacement equation and solve for displacement from here to here. So you have your vertical displacement is 10.37 meters per second times 1.058 seconds plus 1/2 negative 9.8 meters per second squared times 1.058 seconds squared. Do your unit analysis. Your units cancel out, seconds cancel here, seconds cancel out with seconds squared. You have your displacement is equal to 10.97 meters plus negative 5.48 meters. And that would give you a displacement of 5.49 meters from here to here. And because it asks you what the max height is in respect to the ground, you want to take that displacement and just add 15 meters to it, because that would give you the displacement from here to here. So now that you have that, you solve for your maximum height, which is 20.49 meters. So next you want to use the information you have for vertical to solve for your time, for how long it takes for it to hit the ground. So you have your negative 15 meters is equal to 10.37 meters per second times time, because that's what you want to solve for, plus 1/2 negative 9.8 meters per second squared times time squared. And because you're going to want to turn this into a quadratic, so you add 15 to both sides, rearrange it, you have a negative 4.9 meters per second squared, because that's what 1/2 times negative 9.8 is. So negative 4.9 meters per second squared times time squared plus 10.37 meters per second times time plus 15 meters is equal to 0. And that would be a really difficult problem to factor out. So you want to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac over 2a. Plug that in. Negative b, which is 10.37. So negative 10.37 plus or minus the square root b squared 10.37 meters per second squared minus 4 times negative 4.9 meters per second squared times 15 meters. That's your c value. And then put it all over 2 times a, which would be negative 9.8 meters per second squared. So once you simplify this all out, you get negative 10.37 meters per second plus or minus square root of 107.54, that's 10.37 squared, plus 19.6, which is negative 4 times negative 4.9 meters per second squared, times 15. Over here, show your unit analysis. 19.6 meters per second squared times 15 meters gives you 294 meters squared over second squared, which just simplifies to meters per second. And then put it all over negative 9.8 meters per second squared. Now that you have that, you want to solve for what's inside the radical, negative 10.37 meters per second plus or minus radical 401.54 meters per second over negative 9.8 meters per second squared. Solve for the square root of 401.54. It's negative 10.37 meters per second plus or minus 20.04 meters per second over negative 9.8 meters per second squared. Because it's plus or minus, you want to solve for both of them, subtracting and adding the 20.04 meters per second. So negative 10.37 meters per second plus 20.04 meters per second over 9.8 meters per second squared gives you negative 0.99. And you can't have a negative time because that means you're going back in time. You can't do that. So negative 10.37 meters per second minus 20.04 meters per second over negative 9.8 meters per second squared gives you a positive value of 3.103 seconds. Just bring that back over here. That's the time to solve for vertically, and the ball hits the ground at the same time vertically as it does horizontally, so your time stays the same for both. Now that you have the time, you can solve for your, oh yeah, almost forgot. That is the amount of time it takes before the ball hits the ground. So when will the ball reach the ground? At 3.1 seconds. So using that value, you want to plug into your displacement equation, which I put over here. Horizontal displacement. Make sure you specify which one is which so you don't get mixed up. Is equal to 11.52 meters per second times 3.103 seconds. You don't have to use the second half of the equation because your whole acceleration or displacement equation is initial velocity times time plus 1/2 acceleration times time squared. But because your acceleration is 0 horizontally, you don't need to use any of that equation because it's just 0. So displacement is initial velocity times time, 11.52 times 3.103 seconds. Use your unit analysis. You get a horizontal displacement of 35.75 meters, and that's how far out the ball will land.